One more non-mathematical thing I probably should mention before continuing onward here is, I know I don't have the best handwriting. I try to work on it, but sometimes I fall a little bit out of practice, and even when I'm in practice, it's not ideal. This is why I try to do a lot with typing things as well, and pictures, and not being so reliant on guessing what exactly that string of symbols means. But I apologize. Anyway, hopefully it still works. That said, when we're talking about points and lines and positions on a graph, it's good to have one, but one place on Earth, you've already got the origin. Why would you need only one more? You want to be able to describe more complex things. And we want to be able to describe more complex things. You probably want to look at how these two things, your x and y values, might be in a relationship with each other. And that's the role of equations, to be able to describe potential relationships. And later on, when we get further into this book and this material, we'll see that you don't just have equations, you have specific kinds of equations for describing specific kinds of relationships. But for now, that's the most general idea of what an equation is. Although, mathematically, you're probably used to thinking of it in a slightly different way. And to try and marry these two things together, I'll give a rough applied example. So, let's say you get a job. And let's say that either this job takes place 5 years in the future, or you're very fortunate for living in Florida, and they pay $15 an hour. It's obviously a little bit lower for most people, especially in the position of those who are watching this video. But let's say that you are doing somewhat well for yourself. So, you work 1 hour at that job, you get $15. 2 hours, you get $30. 3 hours, 45, 60, 75, and so on. You get that sort of in-out relationship for the number of hours you work, giving you an amount of money. Where if you say, okay, let's make Y the amount of money that you get at the end of a shift, and X the amount of hours you work in that shift, then you would be able to say that the value Y, the amount of money you make, is equal to 15 times, $15 in particular, times the number of hours you work, X. And to put that in mathematical shorthand, because that's what the language of math is, it's a really specific shorthand, you'd be able to say something like Y is equal to 15X. And that's nice. That's somewhat useful, but the truth is, even mathematicians are aware that equations are only so charismatic. When people see an equation, they don't think too hard about it. They just say, ooh, it's numbers. And then they sort of let their eyes glaze over until people start talking about things that aren't math. Which is why mathematicians like those graphs so much, because the pictures, those are a bit more involving. So, we've got this idea, and if we want to get a clearer sense of what's going on there, we can graph those points that we talked about. So you have that point at the origin, which in that case would be the amount of money you get for not working. $0 in 0 hours. Then at 1 hour you had 15, at 2 you had 30, and so on, as we saw. Where we can say that each of those points, those are solutions to the equation. They're points that make the equation true, as it were. And I do say points because if an equation only has one solution, it's not a very interesting equation. You can't get much of an interesting graph out of one point. But for that matter, those 4 points, they're nice. They're evidence. They tell us something. But that's 4 points. We like to be able to do more than just talk about singular things, especially in this kind of class. And for that matter, when you think about your money, if you're working for any sort of decent employer, they will still give you something if you work part of an hour. You'll still make $7.50 if you work a half hour. You'll still make $3.75 if you work 15 minutes. And all those extra values in between, because you get all those extra values in between, and for that matter, keep going onward and upward, well, just draw a line through every single one of those values, and that graph there describes all the possible solutions, as well as, in this case, all of the potential money you could make. Where, in particular, this kind of equation, we can call it a linear equation or linear function. That's the sort of language that we'll see in our next section. And because it's describing a real-world scenario, albeit pretty simplistically, this is an example of a mathematical model, which is something that we'll see more of in the third section, but we'll also see touches of here and there along the way. Anyway, with some idea of what an equation is, what it looks like to graph an equation, what sort of things we're describing here, let's get one more example to solidify the idea.